NEC 404.9c addresses the protection of outlets and devices on branch circuits. The code states where a branch circuit supplies multiple outlets or devices, the individual outlets or devices and the branch circuit shall be protected by overcurrent devices in accordance with the requirements of Article 210 and the provisions of this section. This requirement applies to all branch circuits, regardless of whether they are multi-wire circuits or not. It emphasizes that the overcurrent device protecting a branch circuit must be appropriately rated for the circuit's ampacity, and all devices connected to the circuit must be rated to handle the potential current draw. Now consider a scenario where a branch circuit is wired with number 12 wire, which has a rated ampacity of 20 amps. The outlets connected to this circuit are rated for 15 amps. In this case, the outlets are not rated for the full current that the 20 amp circuit could potentially impose on them. This situation directly violates NEC 404.9c. Even if the outlet manufacturer, like Leviton, provides documentation stating that their outlets are rated for 20 amp pass-through, the NEC mandates that all devices connected to a branch circuit must be rated for the circuit's overall ampacity. Therefore, using 15 amp outlets in a 20 amp pass-through configuration is not compliant with the NEC. The building inspector is correct in their assessment. The NEC prioritizes safety and ensures that all components in an electrical system are adequately rated to handle the potential current they may be subjected to. This prevents overloading, overheating, and potential fire hazards. The code aims to provide a standardized approach to electrical installations, ensuring consistency and safety across different installations and jurisdictions. When selecting outlets for a circuit, it is crucial to consider the circuit's ampacity and the outlet's rating to ensure compliance with NEC standards. Using outlets that are not rated for the circuit's ampacity can lead to code violations and potentially unsafe conditions. Furthermore, the use of pass-through wiring versus pigtailing can also affect the overall safety and reliability of the circuit. While pass-through wiring might seem like a convenient way to connect multiple outlets, it can create a point of failure if one of the connections becomes loose or corroded. Pigtailing, on the other hand, provides a more robust and reliable connection by using a separate conductor to connect each outlet to the circuit. This reduces the risk of a loose connection affecting the entire circuit. Here's a more detailed breakdown of the key concepts. Firstly, branch circuits are the portion of an electrical system that extends from the final overcurrent device protecting the circuit to the outlets. Secondly, ampacity is the maximum amount of electrical current a conductor can carry continuously under specific conditions without exceeding its temperature rating. Thirdly, overcurrent devices, such as circuit breakers and fuses, protect electrical circuits from excessive current flow, which can cause overheating and fires. Fourthly, outlets are points in an electrical wiring system where current is taken to supply utilization equipment. Fifthly, pass-through wiring is a method of connecting multiple outlets in a circuit by using the side terminals of the outlets as a junction point. Sixthly, pigtailing is a method of connecting multiple outlets in a circuit by using a separate conductor to connect each outlet to the circuit. Seventhly, NEC 404.9c is a specific section of the National Electrical Code that addresses the protection of outlets and devices on branch circuits. Eighthly, the National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. Ninthly, compliance is the act of adhering to the requirements and regulations set forth by the NEC and other applicable codes and standards. Tenthly, safety is the primary concern in electrical installations, and all wiring and equipment must be installed in a manner that minimizes the risk of electrical shock, fire, and other hazards. In addition to the specific requirements of NEC 404.9c, there are other factors to consider when wiring outlets in a residential electrical system. These include the type of wiring used, the grounding methods employed, and the overall layout of the circuit. It is essential to consult with a qualified electrician to ensure that all wiring is installed correctly and safely. The NEC also provides specific requirements for the spacing and location of outlets in different areas of a home. These requirements are designed to ensure that outlets are readily accessible and that electrical coils do not have to be stretched across doorways or other hazardous locations. When planning a residential electrical system, it is important to consider the anticipated electrical load of each circuit. This will help determine the appropriate wire size and overcurrent protection for the circuit. Overloading a circuit can cause the circuit breaker to trip, which can be inconvenient and potentially dangerous. In some cases, it may be necessary to install additional circuits to accommodate the electrical load. It is also important to consider the potential for future expansion when planning a residential electrical system. Adding extra circuits or increasing the size of existing circuits can make it easier to add new appliances or equipment in the future. This can save time and money in the long run. The NEC is constantly evolving to keep pace with new technologies and changing safety standards. It is important to stay up to date on the latest code changes to ensure that all electrical installations are compliant and safe. The NEC is typically updated every 3 years, so it is essential to review the latest edition before starting any electrical work. In conclusion, NEC 404.9C is a critical code provision that ensures the safety and proper functioning of electrical outlets and devices on branch circuits. By understanding and complying with this code, electricians and homeowners can prevent overloading, overheating, and potential fire hazards. Remember to always consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with the NEC. When working with electricity, safety should always be the top priority. Always disconnect power before working on any electrical circuit. Use appropriate safety equipment, such as insulated gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity is a powerful force, and it can be dangerous if not handled properly. By following safety precautions and adhering to the NEC, you can help ensure that your electrical system is safe and reliable. Furthermore, consider the impact of using energy-efficient devices and appliances. These devices can help reduce energy consumption and lower utility bills. When selecting electrical products, look for the Energy Star label, which indicates that the product meets certain energy efficiency standards. Energy-efficient lighting, such as LED bulbs, can also help reduce energy consumption and lower utility bills. LED bulbs use significantly less energy than traditional incandescent bulbs and have a much longer lifespan. Smart home technology can also help you manage your energy consumption more effectively. Smart thermostats can automatically adjust the temperature based on your schedule, and smart plugs can turn off appliances when they are not in use. These technologies can help you save energy and money without sacrificing comfort or convenience. Additionally, consider the environmental impact of your electrical system. Using renewable energy sources, such as solar panels, can help reduce your carbon footprint and promote sustainability. Solar panels convert sunlight into electricity, which can be used to power your home or business. Renewable energy sources are becoming increasingly affordable and accessible, making them a viable option for many homeowners and businesses. Regular maintenance of your electrical system is also essential for ensuring its safety and efficiency. Have your electrical system inspected by a qualified electrician at least once every 3 years. This will help identify any potential problems before they become serious. Routine maintenance, such as tightening loose connections and replacing worn-out components, can also help extend the lifespan of your electrical system. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in your area. It is important to check with your local building department to ensure that you are complying with all applicable codes and regulations. Local codes may have more stringent requirements than the NEC, so it is essential to be aware of these differences. Obtaining the necessary permits before starting any electrical work is also crucial. Permits ensure that the work is inspected by a qualified inspector, who can verify that it meets all applicable codes and regulations. Working without a permit can result in fines and penalties, and it can also jeopardize the safety of your electrical system. When planning an electrical project, it is helpful to create a detailed plan that outlines all of the work that needs to be done. This plan should include a list of materials, a schedule, and a budget. Having a well-defined plan can help you stay organized and on track throughout the project. It can also help you avoid costly mistakes and ensure that the project is completed on time and within budget. Communication is also key when working with electricians or other contractors. Clearly communicate your expectations and needs to the contractor, and be sure to ask any questions you may have. Regular communication throughout the project can help prevent misunderstandings and ensure that the project is completed to your satisfaction. Finally, remember that electrical work is not a do-it-yourself project for everyone. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations. Hiring a qualified electrician can give you peace of mind knowing that your electrical system is safe and reliable. Let's delve deeper into specific scenarios related to NEC 404.9C. Imagine a kitchen remodel where you are adding new countertop outlets for appliances. The general purpose circuits for countertop outlets are typically 20 amp circuits. According to NEC 210.52C, countertop receptacles must be supplied by at least two 20 amp small appliance branch circuits. Now, if you choose to install 15 amp rated receptacles on these 20 amp circuits, you would be in violation of NEC 404.9C, even if the receptacles are marketed as having a 20 amp pass-through rating. The inspector would likely fail the installation, requiring you to replace the 15 amp receptacles with 20 amp rated ones. Another situation arises in commercial buildings. Often, you find long runs of circuits feeding multiple workstations or office spaces. These circuits are commonly wired with number 12 AWG conductors and protected by a 20 amp circuit breaker. If you were to install 15 amp duplex receptacles in these workstations for general use, you would again be running afoul of NEC 404.9C. Even though the typical load at each workstation may be low, the code requires that the receptacle be rated for the full ampacity of the branch circuit. It is important to understand that the NEC is primarily concerned with safety. The code aims to prevent overheating of devices and conductors, which can lead to fires or equipment failure. Allowing a 15 amp receptacle on a 20 amp circuit introduces the possibility of overloading the receptacle, especially if multiple devices are plugged into it simultaneously. While a single laptop or phone charger may draw minimal current, a combination of devices such as a space heater, a monitor, and a fan could easily exceed the receptacle's 15 amp rating. The pass-through rating that some manufacturers provide for their receptacles refers to the receptacle's ability to safely conduct 20 amps through its terminals to downstream devices on the same circuit. However, this does not change the fact that the receptacle itself is only rated to supply 15 amps to any device plugged directly into it. The NEC requirement for receptacles to be rated for the full ampacity of the branch circuit is a conservative approach, but it is designed to provide a margin of safety and prevent potential problems. Furthermore, consider the labeling requirements for receptacles. NEC 406.3E requires that receptacles be marked with their voltage and amperage rating. This marking must be visible after the receptacle is installed. This labeling helps to ensure that users are aware of the receptacle's limitations and do not overload it. When selecting receptacles for a specific application, it is important to carefully consider the load requirements and the ampacity of the branch circuit. Choose receptacles that are properly rated for the intended use and that comply with all applicable codes and standards. In some cases, it may be necessary to use specialized receptacles such as those designed for heavy-duty applications or those with built-in ground fault circuit interrupter, or GFCI, protection. GFCI protection is required in certain locations such as bathrooms, kitchens, and outdoor areas to protect against electrical shock. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide detailed information on topics such as grounding, bonding, and overcurrent protection. Staying informed about these standards and guidelines can help you ensure that your electrical installations are safe, reliable, and compliant.